Find the directional derivative of the function f of x and y is equal to 5 minus x cubed plus 3y squared at the point 2, 3 in the direction of the vector u is equal to 2i minus j. Alright, so remember, another way that this question could be put is for you to find the projection of the gradient of the function on the unit vector of u. Right? That's the directional derivative of the function in direction of that unit vector. What the unit vector does is give the rate of change of the function, the rate at which the function is changing. If you measure that distance in the direction of the unit vector, and that rate of change will be maximum in that direction, right? So that's the directional derivative, the maximum rate of change of the function in the direction of the unit vector. So remember now, what you do in finding that is to find the gradient of the function, the dot product between that gradient of the function and the unit vector. The gradient of the function at the point you're talking about there and the unit vector. Alright? So now I want you to write this question down. Pause the video and work it out. Okay, you're finished. What did you get for your answer? Let us see what's going on here. What's the gradient of the function? Remember, the gradient vector of the function is going to be, in this case, we have f of x and y, no z, so it's just f of x and y, is the partial derivative of the function by partial derivative of x. So it's partial f by partial x in the x direction, but instead of saying dx, the change in x is a vector, so you say I, that's in the direction of x, plus the partial of the function with respect to y in the direction of y, that's j. Suppose there was a z, you would have to say plus the partial of f with respect to z in the direction of z, which is k, ijk, alright? But there's no z, just x and y, so this is what you have here. Alright? So now, what is the partial of f with respect to x? Partial of f with respect to x equals, when you differentiate this, what do you get? We differentiate with respect to x, you get negative x. Oh, hold on. It's negative 3x squared that you would get here. Alright? And what about this one? You find the partial of f with respect to y. Well, when you differentiate the function, you get 236 y. That's just 6y. Alright? So writing it in vector form now, the gradient vector of the function f is negative 3x squared I plus 6y j. So there you have that. Alright? Now, what is the unit vector? Now the unit vector is going, oh, by the way, let us just finish off the gradient. Now, at, what's the point again? At 2, 3, right? At 2, 3, that means x is equal to 2, y is equal to 3. The gradient of the function is going to be negative 3 times 2 squared I plus 6 times 3j, which is going to be what now? 2 2 is 4, 4 3 is 12, so that's negative 12 I plus 6 3 is 18 j. Right? You see that? Okay, so let's now find the unit vector. Remember, if you have a number and you want the unit number 1, you divide the number by itself. Alright? Now, here, in this case, we have vector. So it means you're going to divide the vector by the size of the vector. Okay? So it's 2i minus j. So it's 2i minus j divided by the magnitude of 2i minus j, or the size of 2i minus j. So it's 2i minus j divided by, what's the magnitude here? It's going to be the square root of the 2 squared plus the negative 1 squared. So it's 2i minus j divided by the square root of 2 2 is 4 plus negative 1 squared is 1. So it's 2i minus j over the square root of 5. That's what you have. So this can be written as 2 over the square root of 5 I minus 2 over the square root of 5 j. So there you have that. Now, we're going to have the dot product of the gradient vector and unit vector. So therefore, the directional derivative is the gradient vector dot the unit vector. Remember, the unit vector, it has the hat on it. So the gradient vector is what? Negative 12i plus 18j dot 2 over the square root of 5i minus 2 over the square root of 5j. Okay? And then remember that when you do your calculation, you end up with a scalar. When you find the dot product of two vectors, you have a scalar. So now, here, you have this being equal to this times this plus this times this. Just that. The I component by I component plus j component by j component. So it's negative 12 times 2 over square root of 5 plus 18 times negative 2 over the square root of 5. See that? So, you have is 12 twos, that's negative 24 over the square root of 5 minus 18 twos is going to be, in this case, you have, let me check on something here. Oh, where did I get this 2 from? My mistake, you know. Look at this. This is 2is, no problem. But this is 1j. Right? Good thing I had worked it out before. I did it on the screen here. So I remember it's not supposed to be, this part is not supposed to be multiplied by a 2. So this is 1, not 2. Oh, this one too is negative 1. Alright? Okay, so here is minus 18 over the square root of 5. Now it's fraction. You have to remember your fraction. So you just add and subtract the top. And you have common denominators. So it's going to be something over the square root of 5. What is that thing now? It's going to be negative, and it's like 24 plus 18. That's 8 and 4, 12. Bring down the 2, carry 1. 2 and 1, 3 and 1, 4. So that's going to be negative 42 over the square root of 5.